Hello, and welcome to Alchemy of Thoughts. And I'm your host, Dr. Manohar Rao, where we try to simplify science for laymen's through storytelling. Every year, right after Diwali, Delhi wakes up to a grey morning, not from the fog of festivities, but from the stubborn haze of poor air quality. An air quality index that seems to be competing with cricket scores. AQI levels shoot up, becomes national and international headlines. Complaints fill social media, government and opposition ministers taking pot shots, and we citizens collectively wonder, why does this happen every year? But amidst all that noise, very few ask the one question that truly matters: how many of us approach this scientifically? The poor air we breathe is not just smoke or dust, it's chemistry in chaos. We are talking about a complex mixture: fine particulate matter, PM 2.5 and PM 10, small enough to slip through your lungs and into your bloodstream; volatile organic compounds, VOC, that react with sunlight and create secondary pollutants; nitrogen oxides, sulfur dioxide, and a soup of unburned hydrocarbons that come from vehicles, firecrackers, and crop burning. So, when we look at that AQI number on our phones, we are seeing the symptom, not the disease. Without precise analytical measurement, all we have are opinions, not accurate insights for the source of this poor quality air. Think of it like this: if your city's air is sick, then the diagnosis must be precise. The humble air quality monitor gives us a reading, but that's like checking your body temperature without knowing the infection. We need to go deeper. Using gas, chromatography mass spectrometry, GCMS, we can fingerprint hydrocarbons, identifying what exactly we're breathing. Using Fourier transform infrared spectroscopy, FTIR, we can study the molecular vibrations, tracking pollutants as they react and transform in real time. Because here's the truth: what we can't measure, we cannot manage. Now let's look east. A decade ago, between 2010 and 2012, Beijing's air was worse than Delhi's. Smog so thick that planes were grounded. People wore masks long before COVID made it fashionable. But something changed. Beijing launched its Clean Air Action Plan in 2013, a massive science led initiative that combined technology, policy, and public participation. They mapped emission sources with satellite and ground based analytical data, introduced real time monitoring networks using advanced instrumentation, imposed industrial relocation for high polluting sectors, switched homes and industries from coal to cleaner fuels, and here's the key: made air quality data publicly accessible. By 2017, Beijing's PM 2.5 levels had dropped by over 35%, and by 2020, it was hailed by the World Health Organization WHO as a model city for air quality recovery. So, if Beijing could, what's stopping Delhi? We have the science, we have the instruments, but what we often lack is integration between research, governance, and public participation. It's not about banning firecrackers one night a year, it's about continuous monitoring, localized mapping, and actionable data. We need a pollutant fingerprint map, not blame games. We need data driven policies, not reactive politics. Delhi's story doesn't have to end in a haze. If Beijing could clear its skies, there's no reason the world's largest democracy can't breathe better. All it takes is one collective realization that science isn't just for the lab, it's for the living. So the next time you see that AQI reading turn red, don't just sigh, ask, what's in that air exactly? Because the answer to that question might just be the beginning of Delhi's clean air revolution. This is Dr. Rao, and you've been listening to Alchemy of Thoughts, where we simplify science for the common man. Until next time, let's breathe curious, not furious.